Video on Intro to Neural Networks. And so without further ado, let's get started. A neural network is basically a subset of AI. So if we say that, let's say this represents the AI field, neural networks would be around here. And for those of you unfamiliar with AI, a neural network will basically, you give it input, specifically data, like text, images, numbers, and it will produce a certain output. And now the output depends on the task you want the neural network to do. And there are two types of tasks: regression and classification. For regression tasks, you give it data and it will try to predict a value based on that data. And let's say, for example, I give it data about a stock company. Let's call it like data. And then what it will return is, it can return things like price and assets. For classification tasks, we can give it some more data. We can give it data and like an image per se, and it could predict and could classify it as saying, oh, this image here is a cat. So this is a very brief overview on regression and classification tasks, and we'll get more into it in later videos, but for now, it's just a simple overview. And if you haven't realized already, neural networks and other AIs require on lots of data. These things are very data heavy. And let me erase this real quick. Let's get on to the architecture. Here we have the standard neural network architecture: an input layer, a hidden layer, and an output layer. So this input layer is, you guessed it, you feed it data, and then the output layer is the output. And it could be like, and the output varies from the task you're trying to produce and also the data you put in. And what's really important here is the hidden layer. The hidden layer is how you get from data to output. And as you can see, hidden layers aren't just subjected to one. There could be 3, 5, maybe thousands of hidden layers. And the amount of hidden layers can help you create more accurate and better predictions. Now, let's see how a neural network works. And so, all of these little circles here are called perceptrons, P. And so, perceptrons are really important in neural networks because, well, they basically help calculate the output from the data. And let's do a simple overview here. We won't get into too much detail on the nitty-gritty of how to turn this data into something perceptrons could use. So, well, for now, I'm just going to explain perceptrons pretty briefly. A perceptron has, well, an equation. Now, let's call this Wx plus b. And this is, and if you recognize it, it's a linear function, sort of. Just to clarify, actually. And so, what this equation is, we'll explain it in a bit. So W is equal to the weights. X is the input, or the data you gave it. B is the bias, which is just a constant. And then Y is going to be the output of this entire equation. And so, many neural networks have thousands of, and more complex ones have probably millions of perceptrons, and the data gets passed through here, and then the output gets passed to another perceptron in this hidden layer, and then these perceptrons can get passed to another hidden layer, and it'll keep going on, and it produces very complex calculations, and then it gets the output. Now, if you aren't familiar with linear algebra, I highly suggest that you take the classes, because we're going to be dealing with a lot of matrices and vectors here. And so weights biases, inputs and outputs, they're all vectors or matrices. So let's see, call this W1, W2, W3, W4, and then this would be I1, just call it that. This could be B1, B2, and this entire thing could be like, it's called O2, O1, O3, O4, it doesn't really matter. And so, how do we get data and produce an output if all we're doing is having a bunch of linear functions? Wouldn't this just be one big, huge linear equation? No. This is where activation comes in. So let's say a perceptron has the y, it goes through all of this calculations, but we add something else, an activation function we'll call f of, actually, no, we'll just call a. Plus a of x. And this is the activation function. And so what the activation function does is, in order to basically not make this entire thing one huge linear equation, is, well, it produces, it lets certain values go through. It filters the values, basically, sorry. And there are many different types, like ReLU, softmax, tangent, and let me just look. I'm going to show you the ReLU activation function. ReLU activation. Okay, let's do this. Say we have this graph. It's going to be x and y, and this is the ReLU activation function. And what it does is, for any values that are negative, it'll just be 0. But for any positive x values, it'll, depending on the x value, it'll land somewhere on this line, and that will be your output. And through these activation functions, it basically helps to make things more complex, so we can turn something like images into classification, into numbers, and that numbers can help with classification, and yeah. And inputs get, and so for the inputs to be able to be passed into a neural network, they have to be turned into numbers or vectors and matrices. And we'll get more into later videos on how it can do that, but for now you just need to know that everything requires numbers. See, the input gets just turned into numbers. And yeah, this is how a neural network works. I will post a link to this whiteboard down in the chat and down in the comments. And yeah, thank you for listening.